Hello friends, my name is Rohit. We are going to do rationalization today. So this is going to be our first chapter or first session on rationalization. Before we jump into rationalization, let's review some identities of surds. So we are going to revise some identities on surds. We know that square of root A is A. We also know that root A times root B equals root A times B under one root. For example, if we write root 3 times root 4, we can write it as root 12. The other identity is on the division. So A by B whole root can be written as root A by root B. For example, if we write 10 by 3 whole root, it can be written as root 10 by root 3. There are a few examples or few points to be considered for revision on identities for surds. And before we see what is rationalization, and we will start our journey from very simple problem and we'll gradually move towards the more difficult problems. And we'll have multiple videos or multiple sessions on it. Let's see how would a simple brackets get solved. So it is 5 plus root 7 times 2 plus root 5. Let's try to solve this. 5 times 2 is 10. And then 5 times plus root 5 is 5 root 5. Then you multiply root 7 into 2 with a plus sign, plus 2 root 7 plus root 7 into plus root 5. This is root 7 into root 5. This makes it 10 plus 5 root 5 plus 2 root 7 plus root 35. Why? Because root A times root B can be written as root AB. 5 times 7 is 35. We'll do one more problem of such a kind. And see how does it work. For example, it is 3 plus 2 root 2 times 3 minus 2 root 2. If we see closely, we'll find that this is in the format of A plus B times A minus B. We know that A plus B times A minus B is A square minus B square. So if we just replace these values, we find that is 3 squared minus 2 root 2 whole squared. It's nothing but A squared minus B squared. This comes out to be 9 minus 2 into 2, which is square of this 2, times root 2 into root 2. This is nothing but the square of this root 2. It comes out to be 9 minus 4 times 2. This is 4. And root 2 times root 2 is 2. Equals 9 minus 8 is equal to 1. Yep. So we see how do we rationalize now. Now we move to our main topic of rationalization. We will start with the very simple problems of rationalization of the denominator. So before we see that, let's understand what does rationalization mean. Rationalization means that you want to put some logic or some rationale to the fraction of p by q. So for example, a fraction is in the form of p by q, like 2 by root 3. to make it more sensible, you would want to remove this root 3 into a more meaningful number. If the fraction is in the form of suppose 2 by 3, there is no need to do rationalization for this. This is already making sense. If it is in the form of 5 by 2, it is already making sense of 2.5. This seems okay in terms of rationalization. But a problem like this, which is 2 root 3, you would want to get rid of this root 3 factor or the root factor. So let's explore few ideas on how do we remove this root factor from here. Suppose we want to rationalize 2 by root 3. One way to remove this root 3 is to do a square of this. If I want to rationalize 2 by root 3, but if I just do a square of this root 3, I'll have to do a square here. But if I do square on both numerator and denominator, I'm changing the main problem of 2 by root 3. So I'm changing this problem, which means I cannot do a square of denominator and numerator. If I only do the square of denominator, I'm again changing the problem. So that's one problem. So we cannot do a direct square here. The other way that probably we can get rid of this root factor is by just multiplying this by root 3, so that root 3 times root 3 becomes 3. But if we multiply this fraction of our original fraction of p by q by 1 by root 3, we are again changing the problem. So the other way, or the third way that we can talk about is, if you want to get rid of this root factor, is we multiply and divide the entire fraction by root 3, which means this root 3 by root 3 makes the entire fraction looks the same. So the entire fraction of 2 by root 3 is not changing when we multiply and divide the fraction by the same number. For example, if we do a by b times x by x, in the end x and x gets cancelled, the fraction remains a by b, or it may become ax by bx. Here also x and x can get cancelled by each other, and this remains a by b, which is my original fraction. So one way for me is to get rid of this root factor is to multiply and divide by the denominator, so that the denominator gets multiplied by itself and the root 3 factor gets cancelled out. So this becomes 2 root 3 by 2 times root 3 by root 3 into root 3 is 3. So this is my rationalized fraction. We can see another example. The other example could be 1 by 3 plus root 2. Or let's probably we do a similar example of a similar nature. We say that 5 by root 7. We want to rationalize this fraction. The best way for us is to multiply and divide this by root 7. And the reason that we are doing this is because the root 7 in the denominator, when it gets multiplied by another root 7, it becomes 7. So the fraction becomes 5 root 7 by 7. The original fraction of 5 root 7 is actually equal to 5 root 7 by 7. Yep. So let's move to the next type of problem. A little more different from this one. We say that if you want to rationalize 1 by 3 plus root 2. Now this is not just root 2. Had it been root 2, we would have multiplied and divided the same fraction by root 2. Had it been like this only, we would have done an operation like this. So 1 times root 2 becomes root 2, and root 2 times root 2 becomes 2. But this is 3 plus root 2. So we cannot really use a root 2 factor, because if we use a root 2 factor here, this 3 gets multiplied by root 2 and will become 3 root 2 in the denominator. So it is not rationalized. So let's try to see how do we remove the root 2 factor from the denominator. or the root factor from the denominator. We are discussing that one way to get rid of this root 2 is to square it. If we cannot just square this part, we may want to square the entire denominator, and if we do so, we would want to square the numerator also. But if we do so, we'll change the basic essence of a problem. We'll change the fraction itself. In any case, if you want to do this also, this actually becomes 3 plus root 2 whole squared. So it becomes a plus b whole squared equals a squared plus 2ab plus b squared, which is nothing but 3 times 3 is 9, plus 2 into 3 into root 2. So this is 2, this is a, and this is b, plus root 2 whole squared. You get 9 plus 6 root 2 plus 3, because root 2 squared is 2, it becomes 11 plus 6 root 2. Here you see that this part 6 root 2 would still come in the denominator, so there is no point squaring the denominator here, which means that we cannot, or we would not want to multiply and divide this by the denominator like we did in the problem like 5 by root 7. Here we multiplied and divided the fraction by denominator, but we cannot do it here in this kind of a problem, because 3 plus root 2 times 3 plus root 2 would still have a root 2 factor in the denominator. So what is the best way for us to do it? Let's explore another way of doing it is, and we have done this before, we have seen a formula of a squared minus b squared is equal to a plus b into a minus b. If we see this 3 plus root 2, if I multiply this by 3 minus root 2, it actually takes up the shape of a plus b times a minus b. Which means that a squared minus b squared is what? 3 squared minus root 2 whole squared. So this is a squared and this is b squared. It makes it 9 minus 2 equals 7. So we can get only a number, not in surd, not in root, in the denominator if we multiply and divide this fraction by 3 minus root 2. So what we have concluded here is that a problem like a plus root b, we would want to multiply and divide the same fraction by a minus root b. And why are we doing so? Because we want to get a form of a squared minus b squared. If these two factors get multiplied, it becomes a squared minus b, because root b into root b makes it b. Yeah. Let's do one more problem of a similar nature. So another problem of a similar nature is root 3 minus 1 by root 3 plus 1. We want to rationalize this fraction. We'll multiply and divide the same fraction by root 3 minus 1. Divide this by root 3 minus 1, because we want to have this fraction, this part, this denominator should not have a root factor here, should not have root 3. We'll have this is a plus b times a minus b. You see this? Root 3 minus root 1 into root 3 minus root 1 is nothing but root 3 minus 1 whole squared divided by a squared. What is a squared? Is root 3 squared minus b squared equals 3 minus 1. Make it 3 minus 1 here. So here it is root 3 minus 1 whole square by 2. You may want to do further simplification of root 3 minus 1 whole square. Let's see. A minus b whole squared is equal to a squared minus 2ab plus b squared is equal to root 3 whole squared minus 2 into root 3 into 1 plus 1 squared. Here this is 2, this is a, and this is b, is equal to 3 minus 2 root 3 plus 1 or 4 minus 2 root 3. So this can be written as 4 minus 2 root 3 by 2. We see that 2 can be taken as common. 2 minus root 3 by 2, and the answer is 2 minus root 3. This is our answer. Yep. Easy stuff. Okay. We've seen questions of similar nature here.